let's look at Unit 8, Section 2. We're still going to be talking about circles, but we're going to look at tangents, radius, and the tangent relationship. We're going to be touching on Pythagorean theorem and trigonometry in this section. Property here. When two tangents intersect with each other and the same circle, they are congruent. So this tangent is congruent to this tangent. And remember, tangents only touch the circle at a single point. So here, they're congruent. X is 12. Here we have to solve for x. They're congruent. When two things are congruent, we have to solve. We set them equal to each other. So 5x plus 2 equals 3x plus 10. I'm going to get x by itself. I'm going to subtract it. 5x minus 3x, 2x. Subtract the 2. Divide by 2. More often than not, you're not just solving for x. You actually have to solve for a length. And so we're going to plug x back in. 5 times 4 is 20. 20 plus 2, 22. 3 times 4 is 12. 12 plus 10 is 22. And you can see they are congruent. Now when you have shapes that are inscribed inside of a circle, when you have a circle inscribed in a triangle like this or a quadrilateral, the sides of the triangle make a number of tangents. Look at this. Tangent, 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 tangent. And from what we just learned, that tells us these two are congruent, these two are congruent, and then these two are congruent. So let's solve a problem using this concept. This is 5, so this is 5. This is 7, so this part is 7. Well, you notice this whole length is 15. Since this part's 7, 15 minus 7, this part is 8, which is congruent to here, so this is 8. Let's look at another one. Now we have a quadrilateral, but the concept still applies. These two are congruent, so that's 12. These two are congruent, that's 8. Now I got to solve all these unknowns. Well, if this part's 12 and the whole thing's 23, 23 minus 12, 11. Which means this one down here is congruent, it's 11. Well, look, this whole thing's 18. This part of it's 11. 18 minus 11, 7, congruent. So this is also 7. Let's look at another concept. When the radius is drawn to the point where the tangent intersects a circle, it creates a right angle. And look what we have. We have a right triangle. We can solve for a lot using a right triangle. So let me ask you this. Here's a setup. I put some points on here. What do we know about BA and BC? Well, they're both radius. So that means BA and BC are congruent. And that is a property we can use to solve also a lot of scenarios here. Let's look at this problem. First, that's our right angle, which means this is the hypotenuse. Let's never forget that. This is the hypotenuse because this is the right angle. The radius is 5. So this is 5, this is 5. So this full length here, 5 plus 8, 13. Let's solve for x. Well, how do we do that? We know two sides of a right triangle. To find the third, Pythagorean theorem. A squared plus b squared equals c squared. C is the hypotenuse, which is 13. 5 squared plus x squared equals 13 squared. 5 squared is 25, plus x squared equals 13 squared, 169. Subtract 25, x squared is 144. Square root of 144 is 12. Let's look at another problem. Same basic premise. Right angle, radius is 7, so that's 7, and that's 7. Now you could think of this whole length as x plus 7. But that's going to be ugly when you square it. So instead, I'm just going to think of it as y. A squared plus b squared equals c squared. 7 squared plus 10 squared equals y squared. 7 squared is 49. 10 squared is 100. So y is the square root of 149. So the square root of 149 is 12.2. So the full length is 12.2. So to find x, just subtract 7. And you get 5.2. 5.2. Let's look at another problem. Here, we have an angle. We have the radius, and we've got to find x. Radius is 7. That's a 90-degree angle. If I have an angle and one side, how do I find another side? SOHCAHTOA. We're using trig. Hypotenuse, opposite, adjacent. There's no h. OA, TOA. Tangent of the angle is the opposite over the adjacent. X is the denominator. Divide. 7 divided by tangent, 37. 7 divided by tangent, 37. We get 9.3. So x is 9.3. And that's the end of Unit 8, Section 2.